Right, so now we need to set up some constraint geometry for this geometry for the plane. So the way I see it, there's two kind of main parts, right? So if I'm just going to grab a split to show you what I mean. What I want to do is split out again. If I press 9, and then you can see I've got this one kind of the kind of hull of the plane. Click that, press enter. Okay, and that splits out. If I just get rid of the, so that's all one piece, right? And everything else, which comes out here, be, well, another piece, right? So what we can do to check as we're going along, right, is use something called a convex hull to check the geometry. I put this on here. This is going to create a convex hull around everything, but I want to do it per piece. So if I just drop a for each named primitive, these have already got names on them. All right, go to the end. There we go. So that's the geometry that Bullet will see. So once I plug it in, yeah, this is what will be in the simulation, and that's fine. It's, you know, it's less detailed than this, but you know, it's perfectly fine. All the agents are in this part here, and that shouldn't be a problem, right? So let's yeah, look at this kind of ring. So this will be more of a problem if I connect that up. You can see it just makes one big tube and doesn't take into account anything on the inside. So we need to fracture this up, and what we're going to do is use the trusty Voronoi fracture for that. Okay, and we need some points to go in here. So the best way I thought of fracturing this up is, as the geometry is pretty much the same along the length of it, we should just do long kind of strips so that way we have less pieces. So what I'm going to do is just have a kind of ring of points, and then that will create long fracture pieces for me. So I'll just drop a circle to show you, again, to show you what I mean. And let me just visualize this. We can see and position it in the right place. Okay, I just want to Bezier. So I just want points around the edge. Let's make it bigger for 0.6, 4.6, or maybe squish it down a bit like that. Okay, we want it on the XY, sorry, yeah, on the XY plane. It was correct already. And then move it up a bit, and then move it back to the either end, it doesn't matter. Okay, and then I'm gonna add to get rid of the geometry, and then if we connect that up here, and then we should be able to visualize the pieces, I think. So working, let's see. Maybe not. Well, if we, I'll just do this very quickly. Exploded view. And that should show us. There we go. The pieces that we get, which is fine. Okay, and we have control over how many pieces there are with the divisions, right? And let's do a bit more just to be safe. Have a nice, clean geometry. Great. So we got that there, and then we can, so yeah, one thing I want to talk about, I'm just going to drop this down below. So this, you can see here next to the node, we've got these little clocks, which means that it's time dependent. So on every frame, even though it's not animated until frame 100, it's going to be calculating this Voronoi fracture, which can take a while. So to avoid that, another switch, Okay, with a time shift here. Again, this time shift set to just a frame 1. Okay, and then this switch I'm going to configure to switch over on frame 100, right? So $F is more than 100. So when the frame number is more than 100, this becomes true, and I get a 1 here. So we will switch the input to the Voronoi fracture, right? So if you see now, if I play this through, it's running quickly, and then as it gets to frame 100, it stops and starts calculating. Great, and we can merge them back together. Let's go back, connect that up there. We don't need this null. Just kind of organize it a bit. We can Alt and click to tidy this up. Leave this over at the side in case we want to use it again. And let's see, just bring everything down. So I want to combine these together. Okay, I'm just going to put another merge so that we have the chairs and the airplane geometry all going in together. Oh, now we get some colors. Never mind. However, so we've got kind of 3 different things going on. We've got the chairs, which will be active objects, so they want them to be moving around. This will be static, and then the part at the back will be animated. So we need to set up some attributes to take care of that, because they're all going to go into one object in the DOP simulation. So we can override the what we set up. If I show you in the DOP object and here in the packed object, this where is it? Here, this is what we're overriding. So we're going to have active objects for the chairs, and then deforming static objects for the animated part. And the static, even though the plane is static, it doesn't matter. We don't have any animation on it, so it's not going to move. So before I forget as well, we need to kind of pack these up. So we need an assemble, which will give us the name attributes here. So let's call this plane. We need pack geometry, and we want the name attributes on the points. Okay, so we can check that. We got the name attribute there on the points, which is great. And then a wrangle, just to set up our that's active. So bullet attributes on the points, and constraints attributes on the primitives. Deforming is 1. There we go, simple as that. And then on the chairs, we want them active is 1, deforming. We could just delete the whole thing, I think. Yeah, we just don't need to declare that. Great, and then connect that up down here, get rid of this elbow thingy, and that should be all we need. So to save us waiting until frame 100, because I want to see that that's working, I'm going to set the start frame to frame, let's just go to 99. Okay, go in here, and let's go to frame, well, let me set up the camera first. Go inside like that, just make sure we're inside the plane. Great. And then dive inside, play this, wait for it to get to 99, and then I just want to see that the plane is there and that the agents are colliding with it, and then I want to see if the part at the back here moves away. which it doesn't seem to be. So let's see why that is. Go out here, make sure it's doing it here. Okay, so that's working. I can see. So where did, oh, I think I must have copied it over or not copied it, I don't know. Anyway, I've lost those attributes here, so I need, yeah, active 0. Height deforming is 1. It doesn't matter if you've got spaces or not here with Vex. Yeah, that should be fine. So let's try that again. Still no. Let's try that. There we go. So I can see that moving away. The chairs, well, they're basically sat on the floor. They seems to be jumping around. Don't worry about that. I think they're just intersecting the floor a little bit. But I'm going to be playing with the active attributes on the chairs as well in another lesson. Let's just take a look before I go at the geometry. So if I come here and turn on guide geometry, there we go. Yeah, so these are probably intersecting the floor a little bit, but that doesn't matter. Great.